Hello everyone, welcome to Docker tutorial. We'll see what was the challenge before Docker and how did Docker resolve the issues. So these will be our main topics for today. So what was the challenge? So we'll know what was the challenge before Docker and how Docker was the solution to that, and why does Docker or containers matters to us or the IT industry. So and how they work. So basically, for understanding Docker, let's have an analogy for understanding it. So it's a cargo transport before 1960. So here there were multiple goods like the car, and we have a wooden packaging box. Then we have some kind of server, drum, uh, wooden drum, and spices, grains, piano, etc. So we need to worry about how the systems will interact with each other, or how the goods will interact with each other. So we cannot pack the cereals together or with tea or some other thing, because if it gets spilled and it will get mixed up. So those kind of problems were there. Or uh, we cannot pack a car with some other heavy machine, so there may be some dents and other things. So that was the issue here. Other than that, for transportation also it was difficult, like how to carry such heavy stuff, or like very light stuff, and we are using a very heavy lifting equipment. So those kinds of issues were there. So also for the smoother and quickly transfer, like how to do it in an efficient way, as there were multiple methods of transportation and storing available. So in 1960, what happens, where there were a lot of imports and exports happening. So ships cargo used to be transferred as a carrying vessel, which used to have multiple things to be imported, like car, piano, drum, tea, coffee, furniture, rice, cereals, etc. So to reach the market, it again has to go through the various import and export of the countries, local transport, etc., to reach the market finally, and finally to the customer. So in between, there were a lot of things, and it may be like the goods are getting mixed up. So there may be some scratches, dents again to the cards, etc. So simple example would be like coffee beans may get mixed with your tea or rice or some other cereals or grains. So also, like as I explained before, if the car or vehicle are brought through any with another heavy materials, it may get damaged. So how to solve the problem? So here came the concept of containers or packaging material, we can say, in the world of shipping equipments. So they were they built us unique size of dimensionally same or equal dimensional of containers. So so that all of the goods can be fitted into this, regardless of their shape and size. Other than that, like what it solved, the problem was like all the goods were having different dimensions, so all of them could be fit in a single container, and the transportation would be easy and in a smooth manner. And also, like inside the container again, we can have their own safety equipment according to the goods. So it was safe and easy to transport, and this is how the problem was solved in case of shipping industry. Also for transportation, now it can the container can be transported via train, bus, semi trucks, cranes, shipping in ships, etc. Now, now why Docker? So, and how this is in comparison to Docker. So this is again an image, like how earlier we used to transport or the goods from or carry over the goods to the ships. So you can see the huge lump here, and it was like kind of unorganized, and in an unsmooth manner it was being done. So there were like there may be some kind of stealing being happening, or the goods may get spoiled or mixed up with each other, or there were several kind of issues. So this is how it has transformed the industry by using the containers of specified dimension, and everything could be fit, and the safety. equipments can be attached to the containers inside, so that everything is transported in a smooth manner. So 90% of the cargo now shipped are using the standardized containers. Order of the magnitude reduction in cost and time to load and unload ships is like the costs and time is reduced now. Also, there is massive reduction in the losses due to the thefts or damage. Huge reduction in freight costs as percentage of final goods from greater than 25% to it is less than 3% now. This is all due to the massive globalization, and 5,000 ships deliver around, you can say, 200 million containers per year. Now, this is analogous to our Docker or the IT industry. We can say IT industry. So earlier we were using monolithic applications. So each service was interacting in a several way and in a kind of way, and it was tightly integrated with each other. And if we need to update one of the components, it was very difficult to do that. And there were a lot of other issues, like there were multiple stacks available, and how they used to interact. We need to know the behavior about all the components and their interactions. Now the other issue which we had, like similar in the case of the transportation of the container, was like we had trucks and semi trucks, crane, etc. Here we have like we can put the container we can build all the containerized solution for these microservices. But how do we deploy it to your client's machine or client's data center, customer data center, uh, production cluster, maybe public cloud, private cloud, so various other things. So it was again like when it is monolithic, it is very difficult, because once it is running and tightly coupled, it is very difficult to replicate on the other systems of the client or public private infrastructure. So it used to take considerable amount of time and for it to be stable and uh, performing in a smooth manner. So the solution to this is currently shifting over or moving over to microservices. So here, like we have every component being built as a separate service, so which will be interacting with the apps appropriately. So we categorize and we categorize every component and provide it as a service, and then we just build only once in a container, and we can just ship it anywhere, just like our shipping containers. So now the first problem is resolved with our microservices introduction, and the other is resolved like now the containers, the Docker containers can be placed anywhere. It can be your own host, own development machine. It can be some private cloud, public cloud, or customer data center. So you can place it anywhere. It resolves the environmental issues, and like this works on my machine and not on other machine. So all those kind of issues are resolved. Okay. We can imagine how it is smoothly migrating and how quick it will be later once we have the hands-on. So this slide is about the comparison between the physical shipping containers and our Docker. So content agnostic, the same container can hold almost any type of cargo. So similarly, Docker can encapsulate any payload and its dependencies. It is hardware agnostic, so standard shape, and all the shipping containers have standard shape and interface. Allow same containers to move from ship to train to semi trucks or to warehouse to crane without being modified or opened, because it's sealed and more secure, you can say. And uh, it has a smooth transition. Docker, so in case of Docker, we have the operating system is made up of uh, it is using a system primitive like LXC, which can run consistently on any virtual hardware like VMs, bare metal, OpenStack, public infrastructure as a service, etc., without any modification. Content isolation and interaction. So we don't need to worry about anvils crushing banana, or cereals getting mixed up, or uh, rice getting mixed with tea, etc. So containers can be stacked with the required safety equipments. It will be transitioned or transported in a smooth manner. In the case of Docker, we have our resource network and content isolation. So everything is isolated, and it avoids the dependency hell which is in there in the uh, primitive which was there in our primitive uh, architecture of without microservices. Without microservices, that is the monolithic architecture. Now coming to the automation, so standard interfaces make it easy to automate loading, unloading, moving, etc. in case of physical containers. Whereas in Docker, like once it is having the standard operations, just like run, start, stop, commit, search, etc., which is perfect for implementing for CI/CD, auto scaling, hybrid clouds. Now it is highly efficient the physical containers because there is no opening or modification and the scaling part is already reduced. So it is very quick to move between the waypoints because of the standardized structure and the locking or the sealing part. So similarly, Docker is lightweight, virtually no per for startup penalty is there, and it is quick to move and manipulate. Separation of duties. Now again, the shipper needs to worry about the what is the content inside the box, and the carrier worries about the outside of the box. So there is a separation of the duties or responsibilities. Similarly, it is the same in case of Docker container. It is like developer needs to worry about the code, and ops needs to worry only about the infrastructure. Now coming to what is Docker. So Docker is a set of platform as a service. It serves as a platform as a service product that uses OS level virtualization to deliver your packages or software and packages called containers. So containers are isolated. We can have a lot of containers, one for DB, one for front end, back end, etc. For everything, we can have a separate container, and they are isolated from each other and uh, um, by the namespaces, and they can be bundled to have your own software or application running, like whatever are the dependent libraries and configuration files needed for your application, you can put in the Docker container, and they can communicate via well-defined channel. So all the containers may be running a single operating system kernel, and therefore uses very few resources. So whatever you mention or whatever are the requirements of the application, only those things can be put in the container, and that is the reason it is a very lightweight, and also because the containers contains only very few resources compared to the virtual machines, as they have only a single operating system kernel. Now what is Docker engine? So Docker engine is the software which hosts your containers, uh, or helps the containers to run on your machine. So what is the underlying technology is being used? So by default, Docker daemon uses execution driver to create the containers. So basically, your Docker daemon is helping you to create the containers. So by default, this Docker's own has its own run C driver, and it also supports the legacy LXC. Runc is tied to the following kernel features. So now again, the runc driver has features which are attached to the um, kernel features, that is C groups. So the C group is responsible for managing your container CPU memory usage, whereas the namespace is the one which is responsible for isolating one from one container to another, and making sure that the container's file system, host name, networking, processes, users, and etc. are separated from the rest of the system. So now, do really the developers care? We need to build using Docker, or they can still use the traditional? Yes, I can say they should care, because uh, it only requires to build once, and you can run it basically anywhere. You don't need to worry about the package libraries, dependencies. Once you have already covered the pain points of accumulating all the dependencies and libraries in the Docker file. Now every app you run is an isolated container. So the monolithic case can be removed here easily, because every container will be running in itself as a service, you can say, or a container, uh, which enables various versions of the libraries and dependencies to be used for your service. It also reduces and eliminates the concerns of environment and platform compatibility. So earlier, the developers need to care about, like, will it run in Windows, Linux, or various other OSs. Similarly, they need to care about the environment. Like, sometimes it used to work in on their own machine, but not on some other machine, or the cloud, like private, public. So those things are reduced with the help of Docker. And other than that, it is very very fast uh, to run Dockers, and it is very very lightweight, and it runs within a few seconds. Now, do the DevOps team or the infrastructure team or the application team care? Yes. Again, it's because we just need to configure once and it will run anywhere. It makes the entire life cycle more efficient, consistent, and repeatable. It's only because Docker is more and more suitable for your CI/CD, and it is very lightweight, and it doesn't have any dependencies of platforms. That is platform independent. Now, it increases the quality of code produced by developers, eliminate inconsistency between the various environments, like we discussed earlier, like development, test, production. So everything can be used a single container, like whatever is running on your developer's machine, it can be run on any environment. It supports segregation of duties, which we have discussed earlier. Like, now the operation team needs to care about their own part, and developers need to just focus on their own tasks. So Docker helps in segregation of duties. Significantly improves the speed and reliability of the CI/CD process, which we have already discussed. Now, because containers are so lightweight, it addresses the performance issues and the cost reduction, deployment time, and there is no other portability issues which were earlier associated with VMs.